All right, so we're looking at how we can determine the gradient at a point for cubic functions to be specific. So in order to determine the gradient, we want to use differentiation. Differentiation is going to give us the rate of change at the specific point. All right, the rate of change at the specific point. So we've been given a cubic function here, gx equals x cubed plus 3x squared minus 2x minus 5. Now I want us to determine the gradient of the function at the point x equals -1 and at the point x equals 3. So what we're going to do using differentiation, we're going to use the power rule, and this is how the power rule is applied. So we're going to start with x cubed. With the power rule, you always multiply the exponent. So here we're going to say 3 multiplied by the coefficient of the variable. So x cubed, the coefficient is 1. All right, so 3 times 1, that gives us 3. And we're going to put our x here. After that, we always subtract 1 from the exponent. So 3 minus 1, that is 2. So we have 3x squared plus, we have, yes, we got 3x squared here. So we multiply the exponent again, 2 multiplied by the coefficient, which is 3 here. 2 times 3, that is 6. We have x here. And as always, we subtract a 1 from the exponent. 2 minus 1, that is 1. So we have 6 x to the power 1 minus, and here we have 2x. So this x is like it's x to the power 1. All right, so we're going to say 1 times 2, that gives us 2. Then we subtract a 1 from the exponent. 1 minus 1, that is 0. So we have 2x to the power 0. If we remember from indices, anything to the power 0 is the same as 1. So we don't even need to indicate this x to the power 0 because it becomes 1. Then we have a number here, a constant. It doesn't have a variable here. So this number, we don't consider it. It just disappears. All right. So this is what we get after we derive the cubic function, 3x squared plus 6x minus 2. You'll notice this is a quadratic function. So one important point you must remember is the gradient of a cubic function is expressed by a quadratic expression. So the next thing that we need to do is we need to substitute x equals -1 into our quadratic expression in order to get the gradient for this point x equals -1. So first we're going to substitute x for -1. So we're going to have 3, and here we're going to put -1 squared plus 6 open brackets again here, that is -1 minus 2. So -1 squared, that is 1. 1 times 3, that is 3. 6 times -1, that's -6. So we have -6 here. And then we have -2 here. So 3 minus 6, that is -3. -3 minus -2, we get -5. So this is the gradient at the point x equals -1. The next thing we need to find is the gradient at the point where x equals 3. So again, what we're going to do, we substitute x equals 3 into our quadratic expression. So we have 3, open brackets, put our 3 there, plus 6, substitute 3 there, minus 2. So 3 squared, that is 9. 9 times 3, that is 27. Plus 3 times 6, that is 18. Minus 2. So we're going to say 27 plus 18. That's 45. Minus 2, we get 43. So the gradient at the point x equals 3 is 43. And the gradient at the point x equals -1 is -5.